So now, let us play with light. Let us have a simple demonstration of reflection of light with the materials that we're going to use, okay? So for this experiment, we will be needing protractor, pen, ruler, laser, the mirror right here, as you can see, all right, and a clean white paper. All right, this time let us check the law of reflection using a laser and a plane mirror. Okay, the first step will be we will stand a small plane mirror on a sheet of white paper right here. Okay, and let us mark the position of its reflecting surface. Okay, so this is the mirror, then we can use the ruler right here. Okay. So let us say this is the reflecting surface right here. Okay. Now, let us arrange this laser to give a narrow light or a narrow ray of light. Okay, so this is our laser. Again, be careful not to point it at anyone because the light is concentrated and it might be dangerous. Okay, so there you go. There. All right. So now let us direct this ray of light across the paper so that it strikes the middle of the mirror. Notice the reflected ray. Okay. There you go. As you can see, right, we have this incident ray. Okay. So as it hits the surface of the mirror, now you can see this portion right here, the reflected ray. Okay, now we will mark 2 dots on the incident ray and 2 more dots on the reflected ray. Okay, and then we can now remove this laser and the mirror. So let us say, as it hits this surface right here, okay, so where do you think is the reflected ray? Okay, it's around here. All right, and the incident ray, okay, let us just mark a dot right here. Okay, so there you go. Okay, so let us just have it here. Let's move a little. Okay, all right. So now, as we mark 2 dots on the incident ray and 2 more dots on the reflected ray, so we can now remove this mirror and the light source. Now, using the dots as a guide, lay the ruler along the position of the incident ray and draw a line to represent this ray. Okay, so we have this. All right. And there you go. And the other one is right here. Okay. So, at a point where the rays touch the mirror, we can now draw the normal to the mirror. Okay, so make sure it's what? It's 90 degrees or it's perpendicular to the surface of the mirror, and that will be our normal line. Okay, so it must be safer to use this protractor, okay, for accuracy. Okay, so let's have it here and here. Am I at the center now? Okay, let's move a little. And there you go. Okay, so we can mark here the 90 degrees. All right, then let us use the ruler again. Okay, and we can draw this line. Okay, let us have dashed lines here. Okay. All right, there you go. Now, we mark and measure the angles of incidence and reflection. So, where is the angle of incidence? Of course, the angle of incidence is right here. Okay, so we can mark angle of incidence. And what about this one here? Okay, that is now the angle of reflection. Okay, now let us measure the angles using the protractor, of course. All right, so now be careful, because sometimes we're using the protractor in a wrong way. So how do we do that? So now, as you can see, we have this the measurement for the angle of incidence. So, all right. Okay, so we have here 10, 20, 32. So it's around 32 degrees. Okay, what about the angle of reflection? So for the angle of reflection, we can do it this way. Okay. All right. So as you can see, it's also 32 degrees. We have just proven that the two angles have the same measure. All right. So note that to find the angles I and R, we have to draw the normal, okay, again, to the reflecting surface. So this is a line draw perpendicular at 90 degrees to the surface of the point where the ray strikes it. Of course, the other two angles between the rays, okay, and the flat surface are also equal. However, we would have trouble measuring these angles if the surface was curved. That's why we make sure that it's flat. So we measure the angles relative to the normal, okay? The law of reflection thus also works for curved surfaces such as concave and convex mirror. All right, so remember that angles of incidence and reflection are always measured between the ray and the normal to the surface.